My name is Zach Harrington, and I did my oral presentation on experiment 10, thermochemistry and the heat of reaction. Alright, the purpose of this experiment was obviously the introduction of thermochemistry and to measure heat associated with chemical reaction. Also, it was to study heat change during physical and chemical changes. Materials. Well, the first thing you need to do when you get into the lab is make the apparatus behind me, known as the coffee cup calorimeter. I think that's how you say it. And to make this, you need a ring stand, a clamp, the thermometer, and two styrofoam cups on top of each other. You really don't need a cardboard cover, but you know, it's the only picture I can find. Alright, move away. The other materials that you need are the magnetic stir bar, the magnetic stir plate, beakers, graduated cylinders, 1.00 molar of NaOH and HCl, and 2.00 molar of NaOH and HCl. Alright, the procedure for this experiment was first, obviously, to prepare the apparatus, and second, it was to obtain 100 milliliters of both the NaOH and HCl, and you take those and measure 20 milliliters of each solution and put them into a graduated cylinder. And you take the graduated cylinder with NaOH first and pour it into the coffee cup and turn on the stirring apparatus. And right then you would take the temperature of the solution and label it as the temperature initial. Next, you would add the 20 milliliters of HCl, and you would obviously allow the time for the solution to mix, and then take the temperature and label it as the temperature final. Now, next you would repeat this procedure 2 more times until you get 3 measurements that have a change of T less than 2 degrees. And for the next part, when you determine the heat with different conditions, you pretty much just use the same procedure, but as the table shows for trial 4 and trial 5, you will have different volume of each solution for trial 4, and for trial 5 the concentration is different. Results. And the table 2 shows here the mass of H2O, which all you would have to do for that is set up the density equation, D equals M over V. And because the density of water is just 1, the mass will be the same as the volume. So the mass for my example comes out to be 40 grams of H2O. And this also shows you the specific heat of water, which is 4.184. And as you can see here, to get the change in temperature, you just take the temperature final minus the temperature initial. And table 3 here will show you the Q solution and Q reaction, which I'll show you the sample calculations on the next slide, and also the moles of all 3, and how to get, and it shows the heat of reaction in percent air. Now, to get the Q solution, you just use the formula M times specific heat times the change in temperature, which my mass is you take the mass of the H2O, and mine was 40, and you multiply it by the specific heat and the change of temperature, and my Q solution for this example came out to be 870.27. And when you find the Q reactant, it is Q system equals Q solution minus Q reactant, and because the system is thermally isolated, it equals 0. Therefore, the Q solution equals just the negative Q reactant. And then for finding the moles of HCl and NaOH, you just take M times the volume, and in this case it's just 1 times 0.02, which will give you 0.02 moles. And then finding the heat of reaction, you have to change the Q reactant from joules to kilojoules, which will give you, you take negative 8.70 times 10 to the 2 times 1 over 1,000, which will give you negative 0.870, and you take that answer that you get and divide it by the moles of water, which is just 0.0200, which will give you negative 43.5 kilojoules per mole. And then finding percent air, you take the accepted value, which is negative 55.9 kilojoules per mole, and you subtract it from the average, which we just got right there, and all over the accepted value again, and times that by 100, and it will give you, mine came out to be 12.2%. Discussion. Alright, so the question's asked about the difference between why trials 1 through 3 differ from trial 4, the Q reaction, and that is because the trial 1 through 3 has a different volume from trial 4. And then the second question was just basically the same question, but with trial 5, and the Q reaction differs from trial 5 because the double concentration and the temperature double. And then the next question is asked why trials 1 through 3 are similar to the heat of reaction. Why is it similar to 4? And it's because of the double moles. And then for the last question, it asked it's pretty much the same thing for trial 5, and that came out to be, and that was because the temperature doubled and the moles doubled, which it was just a ratio. The ratio was pretty much the same. So, and these are my references.